Good morning, students. In this online class, I will discuss superposition of two plane polarized waves having perpendicular vibrations. So basically in polarization, what we have studied up to this point, we have studied only plane polarized light. But with the help of plane polarized light, how can we produce circularly polarized light and elliptically polarized light? We can understand that concept from this article. So here this is the analysis of the production of circularly polarized light and elliptically polarized light. So first I am assuming that we have a calcite crystal. So here I am assuming a calcite crystal which is cut in such a way that its optic axis is parallel. This is optic axis, and this optic axis is parallel to the surface. So this is the direction of optic axis here. This is the direction. So optic axis is parallel to the surface. So this is a calcite crystal and this is the front face of the calcite crystal. Crystal is, you can consider that crystal is like this. Crystal is like this. And here I am showing you only this part, this front part I am showing to you. So in this calcite crystal, cutting of the crystal is such that this optic axis is parallel to this face. So this is the direction of optic axis and this is suppose x direction and this is the perpendicular direction perpendicular to optic axis, this is y. Now a plane polarized light is incident on this. So basically this front face is corresponding to the side of this board and a plane polarized light is incident on this, like so it will have an electric vector. Suppose electric vector, its amplitude is suppose A. Suppose this amplitude is A and this is making an angle theta with respect to optic axis. So the vibration of electric vibration of the incident plane polarized light is making an angle theta with respect to optic axis. Now we can resolve this amplitude into two components. Along the optic axis, its component will be A cos theta. This will be A cos theta, and in the perpendicular direction, component will be A sin theta. This will be A sin theta. So this is parallel component parallel to the optic axis component has the amplitude A cos theta, and the component that is perpendicular to the optic axis, that is A sin theta. And we are always aware that this component which is parallel to the optic axis, this will act as E ray. So this will, because this component is parallel to optic axis and optic axis lies in the principal section, so automatically this component will be E ray. So the amplitude of E ray will be A cos theta, and the component which is perpendicular to the optic axis or the principal section, that will act as this, that will act as O ray, and its amplitude will be A sin theta. This will be A sin theta. So amplitude of E ray here is A cos theta and amplitude of O ray is A sin theta. So first we have to write down the electric field profile of E ray and O ray. So profile of incident ray, profile of incident plane polarized light. It will have two components. One component will be along the x-axis. I will represent this by Ex. This will be A cos theta. This is the amplitude. And this is sin omega t. Omega is the angular frequency. So this is the x component of plane polarized light that is incident. Now perpendicular component Ey, this will be A sin theta. Its amplitude is A sin theta, and here this will be sin omega t. if I assume that A cos theta is E naught x, if I assume that this A cos theta is E naught x, then this will be E naught x sine omega t. And here I am assuming that this A sine theta, this is the amplitude in y direction, I am assuming it as E naught y. So this will be E naught y sine omega t. So now this is the electric field profile of incident plane polarized light. Now you will say how this is plane polarized. So divide these two equations. So if I divide these two equations, I have Ey by Ex is equal to E naught y upon E naught x. I can write it as Ey is E naught y upon E naught x multiply by Ex. Now this is a linear equation like y equal to mx. So basically these two components, they are representing the incident plane polarized light. So now this plane polarized light is incident on this. This plane polarized light will propagate inside this doubly refracting crystal, calcite crystal, as O ray and E ray. Basically plane polarized light, this plane polarized light, when incident on this doubly refracting crystal, it will resolve into two parts, or it will give rise to two parts as refracted ray, and one will be O ray, another will be E ray, and they will start propagating perpendicular to the board. And if suppose thickness of this crystal is T, so they are traveling T distance along this. So O ray is traveling T distance, E ray is traveling T distance, but their optical part differences are different because refractive index for O ray and E ray is different. So they are traveling equal paths, but their optical paths are different. So the optical part difference will be mu E minus mu O into T. So this will be the optical part difference between them. And if we want to convert this part difference into phase difference, we can multiply this by 2 pi by lambda equal to suppose delta. Delta is suppose the phase difference between O ray and E ray on the emerging side. So what I am saying, a plane polarized light is incident on it inside the doubly refracting crystal. It will propagate as O ray and E ray, and when these O ray and E ray are coming out of this crystal, there will be a phase difference delta equal to 2 pi by lambda mu E minus mu O into T in between O ray and E ray. So this is the profile of incident plane polarized light. Now I want to write down the profile of emerging light. What will be the profile of emerging light? So profile of emerging light. What will be the profile of emerging light? That will be simple. This will be E naught x, amplitude will remain same, its amplitude will remain same, and this sine omega t will be there, but an extra phase difference will be introduced, that is delta. And here this is E naught y sine omega t. So on the emerging side we have this profile of the emerging light. At the incident side we don't have this delta, but when they are traveling as as O ray and E ray, they will create some phase difference between them, and that phase difference will be present when they will emerge out of this crystal. So this is Ex and this is Ey. Now I can write these two equations as Ex upon E naught x equal to sine omega t plus delta. I can write like this, and this equation this equation Ex is written like this, and I can write this equation as Ey upon E naught y equal to sine omega t. Now I will combine these two equations and I will try to find out the polarization of the emergent light. So here I have Ex upon E naught x is equal to sine omega t plus delta. So I can write it as sine omega t cos delta. I opened this term, I expanded this term, so sine omega t cos delta plus cos omega t sine delta. So this is Ex upon E naught x. Now sine omega t, what is the value of sine omega t? From here I can substitute the value of sine omega t. So in place of sine omega t I will write Ey upon E naught y and cos delta. And here I have cos omega t. You are aware of sine omega t. So cos omega t will be how much? Cos omega t will be equal to under root 1 minus sine square omega t. Substitute value here, we can find out cos omega t. So what will be the value of cos omega t? This will be equal to under root or square root 1 minus Ey square upon E naught y square into sine delta. So I have Ex upon E naught x equal to this. This is the first term on the right hand side, this is the second term on the right hand side, this is square root. I want to square this equation, so it will be easy if I take this first term on the left hand side. When I will take this term on the left hand side, this will be with negative sign. So if I take this term on the left hand side, so it will be here minus sign, this will become negative and this will be equal to this one. Now square both the sides. So now square both the sides. Now we will square both the sides of this equation. So on squaring this will become E naught x and this will become square and this under root will become 1 by 2 ki power 1 ki power 2. So it will become like this. This will become sine square delta. So now open this square term. So this will be Ex square upon E naught x square. So this will be Ex square upon E naught x square plus Ey square upon E naught y square cos square delta. So what we are doing, we are opening this term, we are opening this square term and here this is negative sign, so we will have 2 times Ex Ey upon E naught x E naught y. We will have this and this will be equal to sine square delta minus Ey square upon E naught y square and this will be sine square delta. Here on the left hand side we have this term Ey square upon E naught y square with cos square delta. On the right hand side we have same term with sine square delta. So take this term to the left hand side and this term will become Ey square upon E naught y square cos square delta plus sine square delta. As you are aware, cos square delta plus sine square delta is 1. So I can write this equation as Ex square upon E naught x square plus Ey square upon E naught y square minus 2 times Ex Ey upon E naught x E naught y equal to sine square delta. I have this equation, and this is the equation of journal ellipse. This is the equation of journal ellipse. So on the emerging side we will have, in journal we will have elliptically polarized light. So in journal we will have elliptically polarized light on the emerging side. But sorry, here I have forget one thing. Here I have cos delta. So you write down here, this is cos delta here. This is cos delta. This will be equal to sine square delta. So basically this is the equation of journal ellipse, and on the emerging side in journal we will have elliptically polarized light. But this equation is depending upon delta, and delta is depending upon the thickness. This is equal to 2 pi by lambda mu E minus mu O into T in calcite. So basically this delta is depending upon thickness. So if you are changing thickness, you can, by changing thickness or by choosing thickness, you can create any delta in between O ray and E ray. So by creating different values of delta, we can produce different type of polarized light in this case. So one by one I am going to discuss all these cases. So first I am writing this equation at the top. I am writing again. So this is E x square upon E naught x square plus E y square upon E naught y square minus 2 times E x E y upon E naught x E naught y cos delta equal to sine square delta. So now there can be different cases on the basis of the thickness of the crystal. Different thicknesses will introduce different delta phase difference between O ray and E ray, and they will give rise to different type of polarization. So first is case 1. In case 1, if we choose the thickness of this crystal in such a way that this delta becomes equal to 0, 2 pi, 4 pi, 6 pi, like this, then what will be the value of sine delta? Sine delta will be 0, and cos delta will be plus 1. This cos delta will be plus 1. If we substitute these two values here, then we will have Ex upon E naught x minus Ey upon E naught y whole square equal to 0. We will have this equation, and from this I can easily write down Ey is equal to E naught y upon E naught x Ex, and this is the equation for plane polarized light. So if the thickness of the crystal is in such a way that the introduced phase difference between O ray and E ray is equal to 0, 2 pi, 4 pi, 6 pi, then on the emergent side we will have plane polarized light. So if we plot this, then this plot will be like this. This plot will be like this, same. So this is the same profile as the incident ray. So this will be the same plane polarized light. So plane of vibration of the incident plane polarized light and the emergent plane polarized light are making same angle theta with respect to the optic axis. So the same plane polarized light will be observed on the emergent side if this delta is equal to 0, 2 pi, 4 pi, 6 pi. Now come to the second case. Case 2. If delta is equal to pi, 3 pi, 5 pi, 7 pi, odd multiples of pi, then you will see that this sine delta will again be 0, but this cos delta will be equal to -1, and this equation will change into Ex upon E naught x with plus sign here, because this cos delta is -1, so this minus it will become plus and this will be 0. So this will be Ey upon E naught y whole square is equal to 0. I can write this equation as Ey is equal to minus E naught y upon E naught x and Ex. This is again a linear equation, y equal to mx equation, but with negative sign. So this is a plane polarized light and its electric vector will be like this. If this is the incident vector and this is making an angle theta, then this is the incident. This is the incident electric vibration, and this is Ey equal to minus E naught y by E naught x. This was plus. Here tan theta was equal to E naught y by E naught x, but here we have value of slope with minus sign, so we will have on the emergent side we will have electric vibrations making angle minus theta with this. So on the emergent side we will have plane polarized light, but its electric vector is rotated by an angle 2 theta or 2 theta around the optic axis. So here this was the initial orientation of incident light, and this is for emergent. This is for emergent electric field vector. So electric vector is rotated by an angle 2 theta around the optic axis. This rotation is taking place around the optic axis. So this rotation will be like this. This will not, you cannot take this rotation like this. Rather, you will always choose this rotation around the optic axis. So this is 2 theta. So electric vector is rotated by 2 theta if the phase difference between O ray and E ray introduced is odd multiple of pi. This is case number 3. Now, sorry, this is case number 2. Now come to case number 3. Case number 3, if phase difference introduced is pi by 2, 3 pi by 2, 7 pi by 2, like this, and theta, this angle, incident angle, what is theta is the angle between the electric vector of incident PPL and the optic axis. If this theta is not equal to 0, 45 degree or 90 degree. If this is not equal to 0, 45, 90 degree, again you can also write 180 degree, 270 degree. It should not be equal to these angle. If this is not the case, then what will happen if delta is pi by 2, 3 pi by 2, 7 pi by 2 and theta is not equal to this? Then what will you have? You will have this cos delta as 0 and sine delta as 1 or plus minus 1. You can say plus minus 1 here. Now this equation will become Ex square upon E naught x square plus Ey square upon E naught y square equal, this is 0, this term will be 0, this is plus minus 1 square, so this will be 1. So this is the equation of ellipse, and so on the emergent side we will have elliptically polarized light. We will have elliptically polarized light, and more correctly this is more correctly this will be right angular ellipse. This will be rectangular, not right angular, this will be rectangular elliptically polarized light. Rectangular elliptically polarized light. What is the meaning of rectangular elliptical polarized light? We will have on the emergent side, we will have this type of profile. We will have this type of profile on the emergent side. This is rectangular ellipse. So here this is E naught x, here this is E naught y, this is optic axis. So we will have this type of elliptically polarized light on the emergent side. Now case number 4. In case number 4, if we have delta equal to pi by 2, again we have equal delta equal to pi by 2, 3 pi by 2, but this theta is equal to 45 degree. This theta is equal to 45 degree. Then what will happen? This cos delta will again be 0, sin delta will be plus 1. But now because theta is 45 degrees, so E naught x, which was equal to A cos 45 degree, this will be A by root 2, and E naught y, this was equal to A sin 45, this will be equal to A by root 2. So here both E naught x and E naught y, they will become equal. And when E naught x and E naught y becomes equal, then this equation will convert into Ex square plus Ey square equal to E naught x square. This is the equation of a circle. So on the emergent side we will have circularly polarized light. We will have circularly polarized light on the emergent side. So when we will get circularly polarized light, when this theta is making angle 45 degree, it means when the electric vector of the incident PPL, when the electric vector of incident PPL is making an angle 45 degree, then this will resolve into two equal components. In that case, this E naught x will become E naught y, this E naught x will become E naught y, and elliptical equation it will convert into an ellipse. So on the emergent side we will have CPL. So for circularly polarized light, what is important, that delta should be equal to this, but theta should be equal to 45. This is a must condition for circularly polarized light.